Hi, Bill here. This is the evaluation module of my simple chess engine, and it's simply called eval.cpp because it's a C++ source file. So we include our global variables in the global's header file. We've got a couple of functions declared here. Okay, so eval is where it all happens. Okay, so it looks at the table scores. The table score is an important part of the evaluation. So this is just the value of a piece or pawn on a given square. This is updated incrementally, so it doesn't do a full evaluation each turn. It looks up the pawn hash table. If the pawn position has been stored already, it uses that score. Otherwise, it evaluates the pawns and stores them in the hash table. Because every score for the pawn formation will always be the same if the pawns for both sides are on the same squares. In particular, it looks at passed pawns and isolated pawns. So it's pretty crude. It doesn't look at more sophisticated pawn structures. Okay, so the king position's a bit funny because it depends on whether it's a endgame or not. If it's an endgame, it's best to have the king in the centre, so we use one table. If it's the opening or the middle game, we use a different table. You also get a bonus for a piece or pawn in front of the king, which just gives it a little bit of king safety bonus. Not as much as what it really needs, but the program's designed to be simple and quick. Okay, so it returns the side to move score minus the opponent's score, so it scores both sides, and the difference will be the score for the player to move. Okay, so of course we can add more things in the evaluation function. So interval. So we fetch the table scores, which are incremented move by move. We look up the pawn in the pawn hash table. If we can't find that pawn position, we call evaluate pawns. Okay, we add the scores to the scores of the pawn table to the table. So we add the pawn score. Now, if the score is less than 1,000, so it's a fairly arbitrary way of defining the endgame. If the score is less than 1,000, we get a bonus for the king being on a square towards the centre. Otherwise, we get if the king, okay, we're looking at the king position. If the rank is the first or the second rank, and the square in front is white, we add 10 to the score. So that's a bonus for a piece or pawn being in front of the king, provided the king's not beyond the second rank. Okay, so we do the same thing for black. So black is number 1 and white is 0, and then we just return the score. So it's a pretty short evaluation function. Find if you make it too simple, like just being the table score, it does silly things with the king and so forth. Okay, so evaluate the pawn. So what we do is we create this array called score. We set it to 0. We'll loop through the board looking for pawns. If we find a pawn, we see if the pawn is passed. We do that by checking the adjacent columns to see if they have any opponent's pawns in the adjacent columns or the column in front of the pawn. So we're checking for opponent's pawns in front of the pawn to see if it's passed or not. This one checks to see if the pawn's isolated. This is similar. It sees if there's any friendly pawns on the adjacent files. Okay, so that gives a score of -20 for an isolated pawn. And the score of the passed pawn depends on which square it is on the board and which side it is. Okay, so that's done using the passed table, which was initialized in init.cpp. So that's pawn evaluation. So pawn, so this just does a search down a file to see if there's a pawn anywhere on those squares. Pawns 2, and this one's similar. But it starts the search at a certain square, so that way it only searches for pawns in front of pawns. So this function's for detecting past pawns, and this other function's used to detect isolated pawns. So that was a simple little evaluation function, which would be quite quick, but a little bit crude. Okay, so thank you for watching.